All right, looking at this, I'm going to do a quick review over the problems that you can expect to be on your tests on Wednesday. When you're looking at this, before you do anything, you could always, let's say you forget how to do something on Monday, you can always just guess and check, really. Okay, so when you're looking at this, I'm going to guess A, letter A, which is a 90. If you do 90, okay, then you're going to press the stow button, X. It looks like this. You press enter. Then look at your screen, and the right-hand side of that equation has the variable in it. So I'm going to do alpha y equals enter, x over 5. And when I press enter, I got 18, which matches the left side of my equation. So without doing anything else, I already know that A should be the right answer. Okay, 18 equals v over 5. V's on the right side, and with the right side is a 5. The 5 is dividing. The opposite of dividing is multiplying. And 5 times 18 is going to be 90 equals, for every 5 on the bottom, you can cancel the 5 on the top, and you're left with V. Okay, number 2. Same thing, you can use the store feature, but I'm going to do this algebraically, but you could always check it out with the store feature, okay? So when you're looking at this, I'm going to clean up the right-hand side. When I'm looking at this, I see that 1 and positive 4, those are like terms because neither one of them actually have a variable, okay? 1 plus 4 we know is going to be a positive 5. I'm going to write down the other stuff. Now remember, you want to think of this as PEMDAS backwards. So let's take care of addition subtraction. The 5 is adding to R. So the opposite of adding a 5 is going to be to subtract a 5 from both sides. Negative 11 minus 5 is negative 16. Type it in your calculator if you don't know that. And the opposite of 4 times R, so we're taking care of multiplication division, is to divide by 4 on both sides. And negative 16 divided by 4 on my calculator is going to be a negative 4 equals an R. If I wanted to check this once again, I could do negative 4 stores X, negative 4 stores X, and type in the right-hand side, which is 4x plus 1 plus 4. And it gave me the left-hand side, which is a negative 11, so that's how I know I'm right, okay? They check out. They gave me something equals itself. Now the next one right here, I'm going to try negative 41 plus 6x equals 6 times x minus 6. Okay, I want to eliminate these parentheses, so I'm going to distribute to both pieces. Rewrite the left-hand side because it didn't change. 6 times x is 6x. 6 times negative 6 is a negative 36. Now I want to get the variables on the same side. So I just like my variables on the left. So an opposite of a positive 6x is this minus 6x on both sides. Adds up to 0, adds up to 0. And you're only left with negative 41 equals negative 36. And this is actually a false statement. And when you get a false statement, it should be Ghostbuster or no solution. Okay? If you wanted to check it, you could try negative 12. It's not going to give you something. And you could try negative 6, and it's not going to give you something. Okay? So if you want to do this because you didn't know, you're going to find out that neither answer works. Therefore, by default or process of elimination, you're going to find that no solution, answer choice B, is the best solution. Next one, we got negative 24 minus n equals 7n plus 6 times 7n minus 4. Okay, I want to eliminate the parentheses, so I'm going to distribute this positive 6. Rewrite the left side. 6 times 7n is a positive 42n. 6 times negative 4 is a negative 24. Okay, I see that we got like terms on the right. I see 7n and 40n, they both have an n. So when you combine 7n and 42n, you're going to get a 49n. And I'm going to write down all the other junk. Okay, our goal is to get the variables on the same side. Okay, so I want to get all the variables on the same side. I'm going to undo this subtracting in by adding in. Okay, there's also more than one way to do this. So if you did it differently, let's just see if you get the same answers I do. Negative 24, 49n plus, it's really like a positive 1n. It's going to give you a 50n minus 24. Once again, I need my constants on the same side, so I need to move the negative 24n away from the n. So I'm going to do the opposite subtracting, which is adding. These cancel, these cancel. Now, a lot of people would stop right here and say no solution. But remember, negative 24 plus 24, it adds up to 0. That's an actual number. So really, we got more work to do. we need to undo this coefficient or undo the multiplication by dividing. And 0 divided by 50 is going to leave you with a 0, and n equals 0. So I could check this. If I substitute an n equals 0, and 0 stores x, type in the left side, type in the right side, it should equal one another. The next one, we got 20 plus 4n equals 4 times n plus 5. I need to eliminate the parentheses, so I'm going to distribute this positive 4 to both pieces. 4 times n is 4n. 4 times 5 is a positive 20. I want to get the variables on the same side, so I'm going to subtract 4n. That's the opposite of adding 4n. They cancel, and you're left with 20 equals 20. This is a true statement because 20 always equals itself, which implies all real numbers, or you can write out the fancy R either way. Okay, the next one I'm going to remind you, we got a squared plus 2 equals 66. We're still doing PEMDAS backwards. Okay, we're going to take care of addition and subtraction first. So I see that that is a positive 2 or a plus 2 being added. So to undo that plus, I'm going to subtract 2 from both sides. This cancel or add up to 0, and you're left with a squared equals 64. So addition and subtraction is taken care of. There's nothing multiplying or dividing the a, so that's taken care of. And now we need to take care of the exponent. So to undo a square, if you look on your calculator, there's right above the square is actually a square root. So I'm going to take the square root. So second square root, 64. My answer is a equals 8. Square root, that cancels, a equals 8. However, an important feature is that there's a little tiny 2 right there. Okay, that little tiny 2 in the exponent should be a reminder that you should have 2 solutions. So D is not the correct answer. It's a solution, but it's not the best answer. The best answer here is a positive 8 and a negative 8. So if I store in a negative 8 here, negative 8 squared is 64, plus 2 is still 66. So you're actually going to get 2 answers when you have that little 2 right there. Okay, number 7. We got negative 4 minus 5p squared equals negative 154. Once again, we're doing PEMDAS backwards, so we're going to take care of the addition and subtraction first. Okay, I see a minus 4, so to undo a minus 4, I kind of think of the opposite of a negative as a positive. So I'm going to add 4 to both sides. This cancels, and you're left with negative 5p squared equals this plus this leaves you with negative 150. Check that in your calculator if you don't know it. There's nothing wrong with that. We've taken care of addition, subtraction, and next is multiplication, division. I see that negative 5 is multiplying by p squared, so I'm going to do the opposite of multiplying, which is divide. And yes, that's a negative 5 multiplying, so you need to divide by a negative. That's going to change your answer if you divide by a positive, okay? It's the number that's multiplying by p. Those divide evenly or cancel, and you're left with 30. The next step is the exponent. So to undo this square, we're going to do a square root on both sides. Those cancel, and you're left with just a plain old p. And we're going to look in our calculator for the next piece. So when you're looking at this, second square root, it's blue, so you got to press the blue button first, 30. And it gives us something really long, so I'm just going to round it off, okay? 5.4772. That sounds like a good answer, which looks like D. And remember, you have 2 answers because, once again, this exponent right here is a little tiny 2. So that should tell you you're going to have 2 answers. Now let me show you what it looks like, because once again, you can substitute these things in. If you do 5.4772, you store it as x. You type in that left side, which is negative 4 minus 5x squared. You get something close to negative 154, but not exact. But remember, the second you round this answer from that, your answer is not going to be exact when you plug it back in or substitute it back in. So really, when you get something really close to negative 154, don't lack your confidence. Be confident. You're still right because it's really close to negative 154. Okay, number 8, we got 8a squared minus 9 equals negative 78. Undo PEMDAS, so we're going to add 9 to both sides. This is going to add up to 0 or cancel. You're left with 8a squared equals negative 69. We need to undo that multiplication, so we're going to divide by 8 on both sides. And a squared equals negative 69 over 8. I'm going to take care of the exponent, which is square root both sides. And when I type this in right here, okay, when I type this in, I'm going to take the square root of negative alpha y equals 69 over 8. And when I press enter, it tells me no real answers. The reason why is because it's impossible to take the square root of a negative number. There's no number times itself that is real that is going to give you a negative number. Positive times a positive is a positive. Negative times a negative is still a positive. So in this case, we've got no solution. If you didn't know that, you could check all these and see if they get close to negative 78. If none of them are close to negative 78, then you should, by default or process elimination, pick B, no solution. All right, on the back, we've got literal equations, your favorite. Once again, we're solving for x. I look on the same side of x as a negative 16. I know there's no plus sign, so it's not adding, no minus sign in between them, so it's not subtracting, and no division bar, so it's not dividing. So I have to assume they are multiplying. The opposite of multiplying is dividing, and we don't know what g divided by negative 16 is, so I'm just going to write g divided by negative 16. These divide evenly and you get x. If you look at this answer and that answer, just a little different. They brought this negative off to the front or off to the top, okay? There's one negative, one negative. That's the big difference between C and D when you're looking at it. Okay, number 10, you got Z equals B minus A plus M. We're solving for M. Okay, B's positive, so I'm going to subtract B. We don't know what Z minus B is, so I write Z minus B. This cancels and you're left with negative A plus M. Okay, I want to get rid of the M. It's adding, so the opposite is subtracting. Once again, we don't know what Z minus B minus M is, so I'm going to write Z minus B minus M, and it's all going to equal negative A. Now, remember, there's like an understood negative 1 there. To undo that multiplication, I'm going to divide both sides by negative 1. Those cancel, and you're left with this over this, but none of my answers look like that. However, remember, you can break that fraction apart into 3 different pieces. So first piece, Z divided by negative 1. Second piece, negative B divided by negative 1. Third piece, negative M divided by negative 1, which all equals A. Positive divided by negative is a negative. Negative divided by negative is a positive. Negative divided by negative is a positive. So your answer should be negative Z plus M plus B equals A, which looks like D. Negative Z plus B plus M. Negative Z plus B plus M. Reflexive property lets you flip that around. Okay? Next one. First of all, I can eliminate A and C because it doesn't have a line, so it's going to be an open circle. Okay? When X on the left, it points the correct direction, so the answer is D. Okay? It's pointing in the same direction as that arrowhead right there. Next one, I don't have X on the left, however, I can flip it. If I flip K in 1.4, I have to flip this sign too. So it's going to go the opposite. Pac-Man right here, he's eating K. Pac-Man right here, he's still eating K, so I haven't changed the value. I can eliminate C because I know I should have a closed circle because there's a line underneath it. Okay, when I'm looking at this, I'm looking for 1.4. This is at 1.4, this is at 1.4. That one's at like negative 1.4, so I can eliminate D. Okay, variable's on the left, so it points in the correct direction, so it should be B. Also, I know that 4 is bigger than 1.4, and look, 4 shaded in, so that's another way you can do it. Okay, 13, we've got R plus 1 is greater than negative 1. I'm going to solve for R by undoing this addition, which is subtracting. They cancel, and you get R is greater than negative 2, which is answer A. R is greater than negative 2. Okay, next one, we got negative 6n is less than negative 6. I see that those two things right there are multiplying. Opposite of multiplying is dividing. And when I divide, these are going to cancel. I'm going to be left with n is negative 6 divided by negative 6 is 1. But when you divide by a negative, that bottom number is a negative, you got to flip the sign. So your answer here is going to either be A or C. That both says n is greater than 1. However, look at the dots. Open, close, it should be C. Because this right here has an open circle and this doesn't have underline. Okay, let's look at 15. So 15, we've got negative 3x plus 6x is greater than 3. I see that those two things right there are what we call like terms because they both have x's. When I combine negative 3x and 6x, I'm going to get negative 3 plus 6, which is just 3x is greater than 3. I want to undo this multiplication by division. Those cancel, those cancel. But remember, what do they divide evenly into? Well, 3 divided by 3 is a 1. Okay, so my answer should be A. X is greater than 1. Okay, this next one right here. 7 times 6 plus 3r is less than 8r minus 36. I want to eliminate the parentheses, so I'm going to distribute the 7 to both pieces. 7 times 6 is 42. 7 times 3r is a 21r, and it's less than 8r minus 36. Okay, looking at that answer right there, I want to get all my variables on the left or on one side, all my constant on the other side. Me, typically, I like to get my variables on the left. So the opposite of a positive is a negative. I'm writing it underneath the like terms. So I'm going to be left with 42, and 21 minus 8 is going to give you a 13r is less than, these cancel, negative 36. Once again, I need to get my constants on the same side. So I need to move the 42 because it's with the r. So I want to move it away from the danger of the r. Opposite of a positive is a negative. Those cancel, and you're left with 13r is greater than negative 36 minus 42. I don't know that off the top of my head. So if I type that in my calculator, I'm going to get negative 78. Okay? Once again, you want to undo this multiplication. So I'm going to divide by 13. And r is less than negative 78 divided by 13. It's going to be a negative 6. I did not divide by a negative, so you do not flip the sign. So your answer here should actually be C. R is less than negative 6. Okay, number 17. This one, I'm just going to show you how to do it. If, let's just say, you just really don't want to work that out, and you want to just do it all off your calculator. Okay, now these pieces right here, that starting point, remember that's what we call our target. So I want to see if negative 40 or 0 is where I'm going to start my number line. So if I substitute it back in the problem, I should get something equals itself. So let's try negative 40 first, because that's just the A answer. Okay, I stored negative 40 as my x. I'm typing the left-hand side, which is x plus 8 parentheses 3 plus 6x, enter, and the right-hand side is negative 7x plus 24. When I press enter, I don't get the same thing, so I can automatically eliminate A and B, because my target, I should get something equal to each other. Okay, let's try it with 0. 0 stores x. I go up here, type in the left-hand side, go up here, type in the right-hand side, and it does work. Okay, so I know it's going to either be one or the other. Now, the difference is I want to look at the solutions, okay? Looking at the solutions, I'm just going to check 2. So if 2 checks out right, D is your answer. If 2 doesn't check out right, C is your answer, because look, 2 is shaded here, 2 is not shaded here. So 2 stores x. Here's the left-hand side. Here's the right-hand side. And now before I press enter again, I want the left-hand side bigger than the right-hand side. Pac-Man's opening up. And is 122 bigger than 10? Yeah, it definitely is. So therefore, we can say that 2 is a solution. And if you're looking here, 2 is shaded right there. So that's how we know it's a solution. Okay? If you want to work it out, of course, you can use algebra, but I was just trying to show you something different. Now, right here, which of the following has infinite solutions? What you would do is, really, what it means to have infinite solutions, you could not be physically allowed to name every single thing. Okay, so remember, whenever we see this 2, we know there's going to be 2 solutions. So we can eliminate C. Whenever I look at this right here, it looks like there's only going to be one solution because it's an equation. Okay, you could solve it. You could solve this one and you could solve that one. So if I solve 10x minus 1 equals 19, I would add 1, and I would get 10x equals 20. I then divide by 10 and find that x equals 2. That's only one solution, so A is not it. The second one, 2x plus 4 equals 2 times x minus 2. Eliminate the parentheses by distributing the 2x. However, when you're looking at this, the 2x's are the same, but the 4's aren't. So when you subtract 2x on both sides, those cancel and you get 4 equals negative 4, which is false. So therefore, there's no solution for that one. Okay? We just talked about this one right here is going to be 2 solutions, specifically an 11 and a negative 11. But let's look at 5x is greater than 10. When you divide both sides by 5, you're going to be left with x is greater than 2. What numbers are bigger than 2? 3, 4, 5, 6, 7, 8. I could be here all day. And that's what it means to be infinite solutions, that you physically cannot list all those solutions. I cannot physically list every number that's bigger than 2. Okay, we'll be here for a long time. Right here, which is the first step to solving it, you always want to eliminate the parentheses first, okay? If you follow your graphic organizer, you eliminate the parentheses by distributing not a positive 8, but a negative 8. You got to keep the sign that's in front of it, okay? So it's going to be C. D would be the first step when solving this equation, okay? Think about PEMDAS backwards if you get kind of confused. When I'm looking at, there's no addition or subtraction, so that's taken care of. But there is something being multiplied by k, that 2. To undo multiplication, you would divide both sides by 2. Okay? So in those, you're not actually working them out. All you're doing is just telling me what would you do. Those are the cool ones. Okay? Which of the following is the solution to inequality? You can plug those in or you can work it out. 10 is less than negative x plus 2. That's like a negative 1. Even though the 1's not there, you can kind of throw it in there. Eliminate the parentheses by distributing. Negative 1 times x is negative 1x. Negative 1 times 2 is a negative 2. I want to get my variables or my constants on one side. The variables are already on one side. So to undo the subtraction, I add 2. And 10 plus 2 is going to leave you with 12 is less than negative x. Now, I need to undo this multiplication of a negative 1 by division. And when I get that, sorry, a little room up here. 12 divided by negative 1 is a negative 12. I have to flip the sign because I divided by a negative, and those cancel out perfectly. So any number that's less than negative 12 would work. So really, negative 13 will work. If you didn't like it that way, you could do negative 13, store as x. Type in the right-hand side, negative x plus 2. And I want the right-hand side bigger than 10. And 11 is bigger than 10, so that's how you know you got the right answer. Okay, 22, 23, 24, they are the most missed questions off of your last test. So I would say if you don't know what to do, I would write 12s plus 12t. I would write 4 times 3s plus 3t. I would write 2s plus 2t times 6. Me personally, I know that you can distribute this and get 12s plus 12t. And I know you can distribute the 6 backwards and also get 2 times s times 6 is 12s, and 6 times 2t is a 12t. So you're looking at it, each of these come out to be the exact same. So you can either do it by knowing the properties, or you could do, if you didn't know, you could pick up some random numbers for s. So let's say you want s to be 1, you want s to be t, or t to be 2. You could plug them in and see if all the outputs are the same. If they're all the same, they're all equivalent. If one is different, then you can pick something else, or you pick the one that's different. And I'm going to show you this on number 24. Okay, looking at 23, write an expression for the following statement. Once again, this is one of the most missed questions off the last test. You're going to subtract 2 from a number. So the big question is that 2 minus x or x minus 2? If you're subtracting 2 from it, it sounds like the 2 is negative. In this situation, the 2 is negative. So what we're then going to do is we're going to multiply the result by 7, okay? Now we don't know what the result is of x minus 7, so I'm going to put parentheses around it and put a 7. 7 times x is 7x, and 7 times negative 2 is a negative 14. So your answer should have been A. Last one, same thing. If you don't know what to do, you can pick random letters or random numbers and plug them in and see if they give you the same thing. Okay, I'm going to use, I don't know, the number 1, okay? So every time you replace an x, you're going to use it with a parentheses, that number, close your parentheses. So 3 parentheses 1 parentheses plus 3, 1 parentheses plus 3, 3 parentheses 1 plus 9 over 3. Okay, when you type this all in, oh, I never put the over 3 part. So when you type this all in, I'm going to do alpha y equals, I'm going to do 3 parentheses 1 parentheses plus 3 parentheses all over 3, exactly what I've written down. That results in a 4. I'm going to do 1 plus 3, which results in a 4. And I'm going to do another fraction bar, which is 3 parentheses 1 parentheses plus 9 over 3. And that results in a 4. So when you're looking at them, I think I made a mistake, or maybe I didn't. When you're looking at them, all of them are the exact same, okay? So when all of them are the exact same, what you actually, oh, I didn't make a mistake. Okay, sorry. For some reason I was thinking I did. But when all the outputs are the exact same, they're going to be equivalent, okay? So if you don't know, you could always just pick another way of doing this is using your store feature. We know how to use the store feature now. So if I'm going to try a different number, 5 stores x, I can type in the first one, which is 3 parentheses x plus 3 over 3. I can type in the second one, which is x plus 3. I can type in the last one, which is 3x plus 9 over 3. In all situations, we end up with the same output, so we can say they're equivalent. So that's 2 different ways you can do that one. Last one, Bob made a mistake. Okay, he made a mistake. If you don't know what he made a mistake at, I would solve it off to the right separately of Bob. But when I'm looking at this, 4 times 2 is 8. 4 times negative 3x is negative 12x. It's less than 32, so he did good so far. He looks like he subtracted 8 on both sides, which gave you negative 12x is less than 24. And then he divided by a negative 12. He forgot to flip his sign. Okay, so when you have negative 12x is less than 24, when you divide by negative 12, remember guys, you need to flip your sign. Okay, so the negative 2 is right, but you got to flip your sign. So tomorrow what I want you to do is I want you to show the step that he messed up, and it would be good if you just worked the whole thing out. But regardless, you need to write in words what mistake he made, and he forgot to flip the sign in this situation. So I hope that helps you out.